Now, if they are not, if they are going to bring all questions like new questions, the concept is going to be the same from the tutorial sheet. I want you to get me right. That's why I said for you to prepare for physics 1015, you need to go through the tutorial sheet, the test that you wrote, and the past paper from 2020. 2022 is a backup, but the main papers are 2023 and 2024. 2022 is just a backup. Don't go through the 2021 paper. So there are only 3 papers that I want you to go through. So first start with 2023, then go through 2024. When you are done with these 2, that's when you can go back to 2022. Okay? But before you go to 2022, I want you first. So now, what I want you to do is you focus on 2023 paper, 2024 paper, the tutorial sheet, and the test that you wrote. When you are done with these, that's when you can go to 2022. So even if you have not gone back to 2022, but you have gone through the tutorial sheet, the test you wrote, 2023 exam paper, and 2024 exam paper, you are still safe. 2022 exam paper is just a backup. Now, this class, I wanted to clarify on this, and then I wanted us to solve this question. Okay? This question, there is a part that I want to explain. Okay? I know you watched a video, but there is a part that I made a small mistake, but I just wanted to make a video, but I thought of having a class with you so that I explain so that you understand it better. Are we together, guys? Can we start, or do you have questions before we start? Can we start? Okay, so this, we are going to look at this question only for today. The rest are the same. All the answers that I answered, I solved for the video that are there on the website. All the answers are correct, but I just want to make a simple correction on this one. Okay, so this question came from momentum. Now, this question is going to help me to explain everything that you're supposed to know under momentum. Okay, so before we even answer the question, let me first explain momentum for you. Momentum, represented by P, is given by the mass times the velocity. What happens? You have an object, this object has got mass. You want to throw it going in this direction. So this object, when an object has got mass and it is moving at a certain velocity, that object has got what we call momentum. So momentum is a vector. Therefore, it can be negative or positive. That's what you need to know. Okay. Another interesting part is the SI unit for momentum, mass is in kg, velocity is in meter per second. So therefore, the SI unit for momentum is kg meter per second. Okay. Other thing that I wanted to look at is momentum is closely related to impulse. So impulse is given by force times the change in time. The way the time is going to be changing time, the force that gives you impulse. If you look at this, force is in Newton, time is in second. Therefore, the SI unit for impulse, it is Newton seconds. But this part here and this part here, they're actually the same. Let me show you. Force is equal to mass times acceleration. Mass is kg, acceleration is meters per second squared. So if I replace where there is Newton with kg, meters per second squared, per is the same as divided time times s. So one s will go, this s will go. Therefore, remain with kg times meter per second. So that's why these guys and that guy, they are closely related to each other, in case you didn't know. Okay. Now here we have answered some questions which are going to come for MCQ. Whether you like it or not, what I have explained already, we have answered a question which is going to come for MCQ. What I've explained just here, one of the questions which is going to come for MCQ, we have answered. So under this topic, what I've explained, they can't go anywhere. It will be based on this, especially on MCQ. It's either they ask you to say momentum is closely related to impulse, or they'll ask you the SI unit for impulse, or they'll ask you to say is momentum vector or scalar, or they'll ask the SI unit for impulse, or maybe momentum. You get my point, right? Another interesting part that I want you to understand is how are these guys related? How is momentum and how is momentum and what? How is momentum and impulse related? So momentum, I'll start with impulse. Impulse is equal to the change in momentum. This is the relationship. The change in momentum is equal to the impulse. Okay? Now, remember, I want you to understand one thing, meaning that the change in momentum is equal to the mass times the change in velocity. Mass is not going to change, but the velocity is going to be changing. So the change in velocity is equal to the v final minus v initial. Okay? Remember, we said that impulse is given by force times the change in time. So here I'll say the force times the change in time is equal to change in momentum is mass times the change in velocity. So in other terms, we can say the change in velocity is the v final minus the v initial. That's okay. From here, I can, if at all I've been given data for impulse and they want me to find the change in momentum, I can use that data to find that. But what I want you to understand again is that the change in momentum is given by the final momentum minus the initial momentum. So the final momentum is given by the mass times the velocity final. The initial momentum is given by the mass times the velocity initial. Guys, does this make sense? Does this make sense? Okay, it does. So now what happens here is simple and straightforward. When I explain this question, it's going to be very easy for you to to answer these questions. Okay, I can find force if at all I can divide here by the change in t, even here by the change in t. So the average force is given by the mass. So here this is already change in velocity, the change in velocity divided by the change in time. So now what happens here is very simple and straightforward. It's either, if I've been given the final velocity and the initial velocity, I'll use this. If I already know the change in velocity, I'll just use dialect. Then I divide it by time, that is the average force. As simple as that. From this information that we have gathered now, I think we can go back and answer this question. So if you really watched the video that I posted, that I uploaded on website, as we're going to be solving this question, I want you to identify the mistake that I made. Okay? If you're not going to identify the mistake, then you are not watching the video. You didn't watch the video. So now, the question is, during an automobile crash test, a car of mass 1.5 times 10 to the power 3 kgs collide with a wall and rebounds. So this is where now I didn't explain about this word, rebounds, as shown in the figure below. So now what I want you to understand is that the question is saying it goes there, then it rebounds. So rebounds is going back. So when meaning that when it is going back, I want you to understand this point. when it is going back. So when it is going in this direction, we have got the initial speed as positive. When you read any question about momentum, then they ask you, there is a word rebounds. That means that the final speed, it was going against the initial, it is negative. What happens here is simple and straightforward. So now you have to write your data here. Write your data, your initial speed. You have been told that the initial speed is 15 meters per second, meaning that the final speed is now, it is 2. They're not going to show you that it's 2, but from the statement here, the question is saying the wall and rebounds, meaning it was going against the initial. Okay, it was going again, it was bouncing, going back. So this is negative 2.6 meters per second. Okay, then we have the mass as 1.5 times 10 to the power 3 kgs. What else? We have the time t to be equal to 0.15 seconds. Now the first question is the momentum of the car before impact. What are they asking us? Is it initial or the final momentum? Stani respond guys, respond fast, not if mchita hivyo. Initial momentum. So initial momentum is mass times the v initial. So we say the mass is 1.5 times 10 raised to the power 3 times the initial speed. Now it is negative. You have seen it? What am I doing? The initial is 15. So what answer are we going to get? That becomes 1.5 times 10 to the power 3 times 15. Those who have got calculators, I want you to confirm with me. I'm getting 22,500. So the SI units, remember, kg meter per second. Those who have got calculators, confirm with me if this is the correct answer.
Yes, it is.
Thank you. Then now, the next question was momentum of the car after impact. It's the final momentum, right? So the final momentum is mass times v final. So the mass is 1.0 times 1.5. 1.5 times 10 to the power 3 times the final velocity. Now it is negative 2.6. So that becomes 1.5 times 10. 1.5 times 10 to the power 3 times negative 2.6. So it is negative 3 point negative 3,900. Is this correct?
Yes, 3,900.
Negative 3,900. Don't forget the units, kg, like that. That becomes our answer. So your 3 marks here, 3 there, you have got 6. Then now they are saying the impulse delivered to the car due to collision. You want to find the impulse. Okay, so remember one thing. Impulse is given by force times time, but I have time, quite okay, I don't have force. But remember, impulse is close related to the is equal to the change in momentum. Okay, now the change in momentum, so we have this. The change in momentum, we said that the change in momentum is actually the momentum final minus momentum initial. So I'll say the momentum final minus momentum initial. So the momentum final, you might be wondering why they had to put 7 marks. It's because for you to identify that it's going to be negative, few people can identify that. You get my point, right? So you read the question, it's talking about rebounds, meaning that the final speed is negative. So the final momentum is negative 3, like that, minus the initial is 22,500. So meaning that the momentum is those who have got calculators, you can please help me. I'm getting negative 26. So impulse, remember the SI units is Newton second, so I put Newton second. The last question was find the average force exerted on the car during this impact. Like I said, I even gave you the formula to say it is coming from here. So initially this is the change in momentum. So initially the change in momentum is actually negative 2,400 Newton second. So we said the average force, if you can remember the formula that I gave you, it was the change in momentum divided by the time, which is the change in time, which is, we can put the change in time or the time. There was a question which came in your test. They asked about the rate of momentum. Was it the rate of momentum? The SI units for, let me just look at the question, then I read the question for you. I want us to get the units from here. So the question was like this. The question was like what? Am I going to find that question? Okay, here is the question, guys. Oh, I can't find it. But the question was asking about it was asking about the SI unit for the rate of change of momentum. So the rate of change of momentum, they're talking about these, the SI units that we are going to get here. So the answer should be kg meter per second square. It came in your test, because this only on top there you have got kg meter per second, but down here you have got also second, so you square it. So the correct answer there was kg meter s, then they had to put a negative 2 on top. That was the answer. And that question, I think it was question 1 or question 2 for the test that you had, test 2. So find the average force. So the average force we'll find using this formula that I've given you. Okay, another best way on how we can do this is this. Remember we said impulse is equal to the force times time. You want to find the time. So the force, if you have got a question, just unmute yourself instead of you raising your hand, because I'm not going to be able to see your hand. So impulse is negative 26,400. I divide it by time. Time is 0.15. So the force is this answer that I get, I divide it by 0.15. So I'm getting negative 176,000. What is this? 176,000, right? Now this is the average force. Force can be negative, but if the question asks you to say find the magnitude, if they're asking anything about the magnitude, you don't include the negative. Does that make sense? You don't include the negative if they ask you to find the magnitude. So this was the general idea behind this question. Now I want you to go back and look at the question that came in 2024. Okay, look at the question that came in 2024. Can we go back in the group and open the question? Let us go to question 3M. So should I read the question? The only thing, everything was the same. It was the same question. So it was the same question they asked about the impulse delivered to the car.
Question 2C, it was saying an object moves at a constant speed of 9 meters per second in a circular path with
Mm.
radius 1.5.
Mm-hmm.
Find the angular acceleration.
Mm-hmm. What?
Here we are told to find the angular acceleration. So how was the angular acceleration? Now, the angular acceleration was found to be 54. How come? Because here says the constant speed, meaning the acceleration is zero.
Okay, so you missed it, my friend. So now let me explain a bit there. So the linear, in that case, we have got what we call the linear acceleration. You know about that, huh? And the angular acceleration. When an object is moving around the circle, if you are talking about constant speed, okay? So at a constant speed, an object is moving around the circle, the linear acceleration is zero, but the angular acceleration is not zero.